Hello everyone. In this video we are going to be solving problems on trigonometric ratios, finding an unknown angle. In the previous video we solved similar problems, but what we found were the unknown sides. To see the video, just click on the link at the top right hand corner of your screen. Now we know that there are three basic trig ratios. There is the sine, which is the ratio of the opposites to the hypotenuse. There is the cosine, which is the ratio of the adjacent to the hypotenuse, and there is the tangent, which is the ratio of the opposites to the adjacent. So now we're going to be using these three trig functions to solve three different problems. Here are the three problems. The instruction says obtain the value of theta in each of the following. So we can see that the first triangle is a right triangle because one of its angles is 90 degrees. Now we are given two sides. We are given the hypotenuse 13 cm. Of course, this side is the hypotenuse because it's the side facing the right angle. So to make it easier, I can just label this triangle A, B, and C. So clearly, the side AC is the hypotenuse. So I'm just going to have an H. Now, this is the named angle, the angle theta, what we are interested in obtaining its value. So clearly, this side AB is its opposite. That leaves the third side as the adjacent. So we've got the hypotenuse. We also have the value of the adjacent. So looking across these three trig functions, we would see that the cosine makes the cut. So to obtain the value of theta, I'm going to use cosine. So cos theta is equal to adjacent, that's 5 centimeters, that's BC. I'm going to have BC over the hypotenuse, that's AC. So cos theta is equal to BC is 5 centimeters, AC is 13. 5 divided by 13 is equal to 0.3846. Now to obtain the value of theta, I'm going to have to take the inverse cosine of 0.3846, and this is equal to 67.3811. This is the value of angle theta. I can decide to approximate it correct to one decimal place. So this is just going to be 67.4 degrees. That's the value of angle theta. Let's take the next one. Here is the other one. The triangle is also a right triangle because this is the right angle sign right here. So that makes this side the hypotenuse. As usual, I'm going to label it P, Q, and R. So the side RQ is the hypotenuse. Now this is the angle we are interested in, the angle theta. That makes the side PR its opposites, and that leaves PQ as the adjacent. So we've got the opposites and the hypotenuse. Clearly, looking across all three, sine is going to be most useful. Thus, the sine of the angle theta, which we know as the ratio of the opposite here is RP or PR over the hypotenuse, that's RQ. So PR is 7 millimeters and RQ is 9. So if sine theta is 7 over 9, of course 7 divided by 9 is 0.7778. Thus, theta is going to be the inverse sine or the arc sine of 0.7778, and this is going to give 51.0596. I can as well approximate this correct to one decimal place, and this is going to be 51.1 degrees. Now the final one. This is also a right triangle. I'm going to begin by labeling it X, Y, and Z. So we can see that this side here is the hypotenuse side XZ. This side XY, and 6 is going to be named in relation to the named angle. So this tells us that YZ is the opposite of theta. That leaves XY as its adjacent. So we've got the opposite and the adjacent. Looking across all three, we would see that the tan makes the cut. Thus, the tan of the angle theta is going to be equal to the ratio of the opposites, that's YZ, over the adjacent, that's XY. YZ has a value of 6, XY has a value of 2. Thus, we see that tan theta is 4. So if tan theta is 4, theta is going to be the inverse tan of 4, and this is equal to 71.5651. Approximating this correct to one decimal place is going to fetch 71.6 degrees. These are the values of theta across the first, second, and third examples. If you find this video useful, kindly like, share, drop a comment, and do not forget to subscribe. Thank you for watching. See you in the next video.